We are honored to be the part of Current Bangalore. And first of all, I would like to thanks and congratulate to entire Current team for organizing such a wonderful and insightful event. I'm Sashikant Singh, Senior Director and Architect at Shiprocket, along with my colleague, our architect, Kavya Ramya, our Senior Data Engineer, Ratnesh Kumar, and our tech lead, Pratibha Singh. What we'll be covering, let's have a look over there. A brief introduction about Shiprocket ecosystem, how we are using Kafka at Shiprocket, our deployment strategies with Kafka, how we are handling change data capture at scale, and we'll discuss a brief about our data platform, and we'll discuss how we are using seamless Kafka for seamless real-time communication and event processing. Then we'll discuss about our learning and challenges. So, a brief, let's say, at Shiprocket, we are trying to solve the problems for both merchant and as well as for their buyers. So there are the merchant faces challenges at every point of buyer journey due to the poorly stitched ecosystem, which is leading to lower conversion rate, lower conversion rate due to the abandoned cart, limited brand recalls, and low trust on leading to low conversion. Poor checkout experience, delivery, lack of visibility at delivery at the time of the discovery, friction in adding customer details, and inconsistent uptime for different types of payment modes. Poor fulfillment and shipping availabilities in the system, limited next day or same day deliveries, high prices, concentrated warehouses leading to lagging and deliveries. Next, also the problem with the notification and traffic tracking with a limited or lack of timely updates to customers, no insights on purchase intent, and additional cost to RTO in case of the packages being returned. There are problems with the returns as well. The visibility to inventories, lack of delivery attempts, no post-purchase engagement, and no or limited visibility of orders. So every every seller wants to give their buyer experience similar to Amazon is providing. So here we are trying to solve these challenges for the merchants. Amazon has a seamless integration, and every subsystem is related to shipping as a part of its post-checkout experience. This is what we are solving at Shiprocket. Shiprocket is building India's only seamless e-commerce that enables platform over 200 partners, and they are growing. This is a brief details about what Shiprocket is offering to our sellers, merchants. Domestic shipping to more than 19,000 plus pin codes. Cargo shipments, which is national B2B bulk shipment options. Quick hyperlocal deliveries, fulfillment services, warehousing, and other services. We are also providing cross-border services such as which is we are actually delivering over 200 plus countries. CargoX, again, bulk B2B shipping which is we are doing cross borders. LaunchX, which is for end-to-end retail enablement solutions. Checkout, where we are experiencing the buyer experience at the seller's website. Engagement, WhatsApp-centric e-commerce platform that we are building. Promise, to enable the trust by the buyer to leveraging their purchases. And we also recently integrated ONDC for better visibility, enhanced visibilities, right? So at Shiprocket, the scale is we are handling over 1 million orders every single day. The writes that are happening to database is over 2.5 billion every day. The amount of inserts and updates that we are doing is around 3.5 terabytes every day. This is let's have a look at the number of the event that we are processing at Kafka is close to 1 billion every day. Webhooks that are incoming and outgoing includes 22 million webhooks every day. Buyer communication, 26 million communication every single week. The data size that we publish is around 1 terabyte every single day. So I'll ask my colleague to continue yeah.
So good evening, everyone. Glad to have you all here. So I think since it's a data streaming event, right, main thing is obviously Kafka. So what are the use cases of Kafka at Shiprocket? So more than Shiprocket, let's say it is the entire e-commerce ecosystem. So what are the use cases? What is exactly e-commerce? Everyone knows. So we get lot of orders in a day, we get billions of orders, and then we get lot of status updates. And so we get lot of orders, status updates, lot of these events happen in a day, right? So all of these events, we need to handle it. So for that, one of the use cases, this one. Yes. So now lot of status updates, order update that come to our system, right? Ours is a microservice architecture. So basically any update that we get it to different services which cater to different needs. But these have to be communicated further to downstream services because we further operate lot of things based on any order or status changes. So that is one of the use case. So next one is, since we have buyers also, we have to notify them about any status updates or anything that happens. And post-purchase also, we have to engage our customers, right? We have to get them back to our system. So we have to do some marketing as well. So for all those communications, whether it is via SMS, email, WhatsApp, these days, so we are using Kafka here as well. So one more thing is, see, we are onboarding sellers onto our Shiprocket. Be it a small scale enterprise user, he can be some small scale shop seller, or it can be an enterprise seller. So we have a range of sellers. So each of the seller has to maintain their wallet in Shiprocket. So what exactly is wallet? Basically it's their account. We charge for our service, right? Whether it is a forward shipping charges or return shipping charges, or we provide lot of value added services like Shashi has explained what all comes into our ecosystem. So for each of them, we have to add some charges. And like I said, microservice architecture, you have different data, different places. You have to integrate all of the data to calculate his final charges. So for all those things also, we use Kafka as the backbone. So next thing is obviously everywhere real-time is a major use case where we have to derive insight based on the orders data that we get, the buyer insight we get. So a lot of insights we have to derive. So obviously for real-time analytics, we are using it. So we do a lot of business insights based on the data. Now other thing is, so this user activity, right? There are several platforms, we have a lot of products. So we have to collect the user data from everywhere. And like I said, like real-time analytics, we have to analyze his behavior. And you know, there will be a lot of high volume data. It is not just his order creation or order update. Wherever which product page he viewed, anything, whether he viewed something, whether he clicked something, the entire activity, and that's billions of events that keeps coming. So for that also we use Kafka for tracking. Next thing is webhook. So like Shashi explained, right, there are 200 plus partners that we need to include, because we are an e-commerce enabler platform. We have to integrate with multiple platforms which are already built in. So we will have to do a lot of integrations inbound, with inbound calls we will be getting. We'll have to do a lot of outbound calls. We have to ensure it is fault tolerant. So for all those reasons, we use Kafka. So these are few major use cases that we have at Shiprocket. So now, why did we choose Kafka? So what are the main reasons that we had to choose Kafka? Because there are out there several other alternatives as well. So first reason is high availability. So what does that mean? In our e-commerce, we get lot of orders in a day, and we'll get orders throughout the day. There are people who will order at 3 a.m. in the night, also 4 a.m. So we have to keep our system uptime 24/7. So Kafka has that high availability because it has this distributed architecture and it has replica concept, which is a great thing. So with all those things, we have high availability use case. Next, high performance. Obviously, we have billions of events coming in our system. So we need something which is very fast. So for that reason, Kafka is suitable. Now, what is fault tolerance? Obviously, due to replica concept, right, even if one broker goes down, there are other brokers which can take over the leadership of the partition. So for that reason, we need fault tolerance, because we don't want to lose any data of any buyer or any order information. Next is persistent storage. So like everyone knows, Kafka has a retention period that you can configure at a topic level, right? Why do we need it? At least if you want to replay the data at later point of time, or we want to do some auditing later. So this persistent storage is very important. Next, real-time processing. Obviously, everywhere we see Flink these days. KSQL was there, now we have Flink everywhere. Everywhere you see it is all Flink. So obviously, real-time data processing, that is data manipulation, transformation, is very important. So with Kafka comes lot of streaming applications. So that is one of the use case. Next is enterprise security. Obviously, with more and more enterprise-related product it becomes, the more challenges are with security. So one thing Kafka provides is, be it a SSL encryption you want, or user level authentication you want, or you want to limit a user to a particular topic. For example, you can only produce to certain topic or consume from particular topic. All those restrictions, very granular level, is provided by Kafka. So these are our major reasons why we decided to go with Kafka. So no going back. So now, how do we deploy Kafka at Shiprocket? So obviously, most of the technologies that we have in our current modern, right, they provide both managed service as well as an option to do in-house. So obviously, what did we choose? See, each one has its own pros and cons. If you go for a managed service, obviously you don't need a fully expertise team. You can go with them. And then another thing is, you don't have the headache of the system will not be available or any such problem. Now in-house, like I said, maybe we might need it because you can fine-tune a lot of configurations, you can play around, there are a lot of things that you can still do. So what did we choose? We went with a hybrid approach. So we have both Confluent-based as well as an in-house system. So why did we choose? Because there are several constraints to take care. There is no one way to go. We need high availability. We also need some cost efficient for certain places. And we also need a robust high performance system. So to start with, Confluent we have. So where do we use Confluent? So whichever is direct customer facing or a very critical data system, which you need it 100% availability almost. So for those critical operations, we are going with Confluent managed. So like most of you have seen the stalls, Confluent Cloud, everyone knows it provides this managed service. So we went with Confluent, and along with Kafka backbone, right, we do use lot of other managed components like Kafka Connect. So if you want to connect to any external system, to and fro from Kafka to database, or for example MySQL, Elasticsearch, anything you want to go in and out, so we have to use some connectors. That is one thing. Next thing is KSQL. Obviously, if you want to do any data manipulation, like I said, so we use KSQL, Kafka Connect, provided by Confluent itself. Then we do use schema registry if you want to restrict to a particular schema for a data. So that is also we are going with a managed Confluent. So like I said, use cases, critical workflows. Next thing is, like I explained, in-house Kafka system. First thing is, we don't have to have any managed service fees, or anything. So that is one reason. Second thing, you get a full control. You can fine tune your performance, certain configurations you can fine tune, or you can use resources very well. So that is one more. So like I said, use case, it's a less demanding or you can say little less critical services, but still important though. So we do use it for real-time analytics, and we do use it for all our this lower environments, all those things. We do use in-house Kafka. So in-house Kafka, how are we doing? So nowadays Kubernetes is getting very common. So Kubernetes is a container deployments, right? Where it is providing automation, scaling, and lot of maintenance Kubernetes does. So we thought, let's try it on Kubernetes. So that's why now directly if you want to natively deploy on Kube, right, it will be a little bit difficult because you need to understand lot of things about Kubernetes and all those things. So there are already some open source operators which help you deploy Kafka on Kube. So one of such tool is Strimzy. So we went with Strimzy. Like I said, Strimzy, you don't have to know a lot of native things. It will give you a lot of flexibilities related to deployment, scaling, all those things. Next, second thing is, so Kafka, it is obviously stateful. So you need to ensure your data is not lost, even if one of the node in EKS goes down. So to ensure that, you have to go for something called persistent volumes in Kubernetes. So even if your EC2 goes down, if a new node comes up, you can still attach the disk back to the new EC2. So for all those things, we use something called JBots, where we have multiple disks we associate for particular missions. And that is all automated. Next, so now more and more nodes you have, right? So there will be a lot of nodes you will have to manage whenever a broker goes down. As you all know, Kafka partitioning, the default partitioning rebalancing strategy is a very basic one. So you need a better one. For example, based on probably rack, if you are aware, rack physical unit, right? Where do we store? If you want to ensure that there is a rack awareness, which means you want to ensure your data is not lost even if one rack goes down. So you should be able to ensure your partitions are distributed across your different nodes. So maybe you will have to balance on disk space also, because you don't want to bombard only one node with lot of disk. And let's assume you had only like 3 or 4 nodes in a mission. Now more and more load came. Then you start adding more nodes. If you didn't have cruise control, what would happen? New load will go to the new services also, but the old nodes were already up. They were already loaded. So Kafka has, if you have to rebalance, you need to do a manual rebalancing where you have to move the data from one node to the other one. So, but cruise control is another open source tool mainly provided by LinkedIn. So what we can do is we can rebalance automatically as well. And based on lot of parameters are there, whether you want to do it on disk space, whether you want it on number of replicas per node. So there are a lot of such factors which are given by cruise control, and you can fine tune a lot of things. It has lot of goals, like lot of parameters. So that is a one session altogether, I think, to give it on cruise control. So I'll just move forward. Now, like I said, Kafka, we use Kafka Connect, KSQL, schema registry. So we discussed about Kafka, but what about the other subcomponents? So all subcomponents, we have kept it on in-house and on Kubernetes. So be it Kafka Connect, Strimzy operator does provide on Kafka Connect also to deploy it on Kubernetes. So we use that. Then we have schema registry as well as KSQL. Again, on open source we are using. Similarly, for monitoring, we use Prometheus to collect the metrics, Grafana for visualization. Then we have an admin panel of our own, so which we use for all the operations and everything. So I think with that, we'll conclude mine. So Ratish from our team will take you forward for the data platform. Thank you, everyone.
So we are at Shiprocket. We are developing a stable and scalable data platform. Right. So we are leveraging Kafka streaming technology to build a robust data platform which is highly scalable, cost efficient, and democratized data platform comprising new modern era data pipelines. So in our system, we have multi-tenancy system which has over 1400 MySQL database, including 50,000 tables, and each database content tenant specific data. Although this design provides flexibility and security, but extracting the analytical workflow from these database is quite complex and time consuming. So we can see what is multi-tenancy. Each tenant database is separately getting stored in different silos. But when we talk getting the real-time analytics from those systems in the near real time, it is very complex task, like getting a simple KPIs at the centralized level. Suppose that we want all the order level KPI, we need to iterate over 1400 databases to get the single KPI. For that, what is the challenge basically here? The multi-tenant complexity, like each tenant operated in isolated database schema, and schema is also different for all the tenants here. So the second thing, managing and querying decentralized data for real-time analytics was a really bottleneck for us, and demand for the speed, like iterating 1400 SQL database and getting the KPI become really slow. So for this, we use Kafka streaming to get the data collect at the Kafka brokers. Here is our architecture for the data platform, our data platform. Like we have multiple sources. From these sources, we use Debian connector to collect the CDC logs, which further push to the Kafka event, and it also maintains, we use Kafka registry for schema evolution. After the data collection, we use Amazon EMR service to process that data, and after processing that data, we use S3, and on the top of that, the open table source format Iceberg and Hive tables for storage layer. On the top of that, for the query purpose, we use Trino, and for the dashboarding and reporting system, we use Metabase. So the data collection from the different databases, we use again Debian, and we use every format to publish the message, which is highly memory optimized, and schema registry again to maintain the standard schema of every tenant database. We are managing here 15,000 plus topics to get the data from all the tenants. For the data processing, we are using AWS Lambda, which is dynamically creates and manage our EMR clusters, which is triggered by the event bridge, and it's also ensure the efficient and cost-effective data processing. On the top of that, on the EMR cluster, we use our PySpark job, which is basically unified tenant-specific data streams, resolve data silos and schema inconsistency, and it also performs some critical data transformation like standardizing schema, cleaning and enriching the raw multi-tenant data, converting data into unified query-ready Parquet formats. After processing that data, we store that Parquet file in the S3 folders, and we use medallion architecture like bronze, silver, and gold layer architecture for better and efficient data management. And for the metadata management, we use AWS Glue service and Hive Meta Store for modern era table formats, open source table format. After that, for the query, we use Trino, which is basically enables fast distributed query across diverse data format directly from the S3. Seamless data integration with the catalog management like AWS Glue and Hive meta stores. And after this for the users, we use Metabase, which provide user-friendly interactive dashboards and analytics, empowers business users to create their KPI, their visualization without writing SQL. It's a drag and drop kind of functionality provided. Other than that, we can use that data by providing other business BI tools, external business tools. That's all.
So, at Shiprocket, we were microservices architecture, but there were some primary problems with the microservices architecture, that all the services are actually dependent on the other service. Events produced by one service is actually managed by other service. It is like you are cooking for your neighbor, right? So inter-service communication, again a painful, just in case your service, you want to break your service into multiple services, so then there also is a problem. Splitting that into smaller services, now you need to resolve all those dependencies with that particular services. Multiple services need same data. You end to duplicate the same data multiple times. Hard to manage and develop. Invalid events. There are situations where you produce multiple invalid events. And also, what about the manual updates to the database? That won't produce any events. Now, with the Shiprocket, we are using a decoupled event production. So here, the solution was all the events are updated to the database. Now, that was the 100% truth that we can resolve by using this. If we rely on the database, then we can produce all the events. Events mostly are being produced and by the core application and saved to the database in the form of upserts. Binary logs were the 100% truth that we can follow to take out the events. Now the challenges with the approach was reading the binary logs, large number of updates that is happening in the database, producing over 300 GB of binary logs every single day. So, to handle this, we have designed an architecture where we are actually capturing all the binary logs and managing them with the help of Kafka and KSQL. Let's have a look at the KSQL that we are actually running. Stream processing, KSQL basically is a stream processing engine that allows you to query real time the events that are being produced. Built on the top of Apache Kafka streams, supports filtration, extraction, aggregation, joins, and also stateless and stateful, is capable of doing stateless and stateful transformations. So, here are some snippet of code where we can read the topic from data and structure as a stream. These streams supports JSON format, Avro format, and protobuf format. This is an example where we are creating a stream out of the binary log that we have streamed to a JSON topic. A topic. Create a stream transaction ID string, user ID, double, amount, transaction type string, timestamp, begin, and this is how we create this. Now this data goes to transaction topic. Now we have all the transaction to the system, and now we can process them. Creating a sync stream, writes, transform, and new topic how useful for filtering and aggregation of transformations. Create a stream with values where amount is greater than 5,000. Now we have a filtration here. So similar, we have multiple filtrations we have used. So yeah, now over to our colleague, Pratibha.
Yeah, hi everyone. As Shashi has already told what is KSQL, basically I am looking how we are leveraging KSQL for the multi-wallet seller system for the passbook and for all the sellers. Basically we operate with the multiple microservices, and each microservice has their transactions. So what we are doing, we collect all the real-time transactions, and then we manipulate the data, filter the data and process the data, then we calculate the data in the wallet system. Once wallet has been updated, we will see all the log activities and transactions in the passbook. We are using KSQL for the wallet and passbook. You can see in the diagram, all the data is collected from the microservices and is processed through the KSQL. Then we connect to the Kafka topic and it's consumed by the wallet services. From the wallet service, we are processing the passbook. And when we are leveraging all the KSQLs and other things, we face multiple challenges. So where we are seeing what kind of challenges we face and how we have overcome. One of the basic challenges was a huge data, because we are using lots of data on the daily basis. So what are the challenges is the data size. So initially we were using JSON. Now we have just come to the protobuf and Avro format, which also reduce the data size and other lots of things. Next challenges we have here, the connection pool management. Like Kavya has already told, in webhook we are consuming multiple events in a daily basis. So what we are doing, for every connection we are for every data topic producing data, we are making connections. What we say that our load has been increased, so we have implemented a pool. And you can see the differences in the graph. Initially we are making connection for the every transactions and every topics. Once we have using connection pool and channeling in the Go language. Basically we are using Go in that as a tech part over here. You can see the differences, what kind of load differences initially and what we is after using the pool connections. Another one is the database CDC data filtering, because lots of data was there and lots of multiple microservices are producing the data at the same time. So what kind of challenge, basically how we filter data in such a way. So we have replaced, because we are not, initially we are using a single microservice which we consume all the data and filtering data. Apart from this, we replace this microservice, the KSQL, which leverage the data for the filtering and processing and maintaining the unique transaction IDs and order of the transactions. Next one is the uneven data load distribution, because partition key is very important. You cannot decide the data is like one of the partitions are loading all the things. So when we are creating partitions, the partition key is playing the critical role. So we have introduced the proper key for the partitions so that even distribution of the message across the partitions. That's it from our side. Any questions, answers?
Thank you, Pratibha. So we can open up for questions.
How big was your KSQL DB cluster as well?
So coming to, we do use Confluent as well as in-house, right? So in Confluent, almost, I mean, we get it as based on pool concept. Like they charge on the one cluster for, we have one cluster for Kafka, and then we have one cluster for Kafka KSQL as well. So those are the two pools that we are using currently. And coming to in-house, so we have a 3-node cluster. Almost it is 8 core and 64 GB heap memory.
Yeah, just interested to know how is the load distributed across your hybrid cluster, the Confluent one versus the in-house one?
So basically, like I said, right, currently in-house we use it for our lower environment, be it development or QA, and then we use it for our data platform. So our complete data platform is on in-house. And our critical workflows of order, shipment updates, buyer communications, those are on Confluent.
Hello.
Hi.
Why is the difference, like for one cluster you want to go with Confluent and one with your on-premise? That's my first question. And the other one, when processing the streams, you have multiple options like KSQL or Kafka streams or Flink. Why did you choose KSQL?
So we started with KSQL basically because we were exploring for Kafka, and then we started with Confluent managed services only. So in that, when we explored, first came is KSQL. That time Flink was not a fully developed solution. So if you ask me now what would you use, obviously we will use Flink because it's going to almost replace your KSQL. So we have already a plan to migrate to Flink.
About the difference between your on-prem versus Confluent.
So okay.
Why not a single one? Why is it?
So one of the factor is cost, obviously, because data platform you need data from lot of databases, and like our colleague explained, right, there are 1400 databases and there are 50,000 plus tables which have different schemas. It's not consistent because when we started with sellers, right, they had their own requirement, their own flexibility they wanted. So with all those things, right, you wanted to get data from different tables, and they also wanted several schema constraints. We had to go with lot of topics, lot of partitions, almost 50,000, 60,000 plus partitions. So with all those things, considering one of the factor as cost as well, so we went with in-house. So that was our major one.
Basically, we have breaked our system in two things. One is the high availability, and where is the cost efficiency. So there is no need for the high availability for the data platform. So we have choose in-house, and for the production system where high availability is required, so we choose a self-managed system.
Hi, great talk. I have a question on the passbook use case that you talked about. How do you ensure data consistency in case of passbook use case? For example, in your pipeline, you could lose events, right? And event loss is sometimes you can't avoid. So how do you ensure data is consistent and passbook reflects that?
Basically, we capture all the transactions from the data events, and every events we filter the data based on that key it is required or not, and we ensure transaction IDs in each transactions. So we ensure every transaction should not be duplicated, so that we can sometimes its data has been missed, so we can reconcile and we can ensure the data is in that way.
Is reconciliation possible when you have so much of billions of events?
Most of the things we don't miss the events. Basically, in most of the cases, it's hard once in a billion kind of things, because
I would say that we have chosen the database as a event production. So missing some event from the database itself is near to, that is very rare, right? Again, if you say that if the older architecture would have been, so then you might have missing events as well. But here in the case, it doesn't happen that.
Okay, thank you.
Hi, actually Debezium guarantees only at least once processing, right? So how do you manage data duplication?
We tend to manage this on the behalf of we had a log position. We have log position in every event. So whenever a new duplicate event comes that has already been processed, we ensure that if the duplicate event comes, then we can handle with the help of log positions. Every data updated will be logged as we are using the binary logs. Then we have log position with that.
Got it. Thanks.
So you have mentioned per tenant per database, right? Why you have chosen this architecture? Why not the global database? Because having multiple database and having thousands of tables and all, it reduces the latency, right?
Right. It is one of a product or warehousing services. It is not the Shiprocket. It is the warehousing services that we have onboarded, and it was a historical reason they have done it. If you choose today, then we would have gone through a single database architecture.
And there is another question: why there is no SQL database instead of RDBMS? You have seen.
We are using RDS.
We do have Cassandra, Postgres.
Okay.
So wherever we need heavy writes, right, we do have Cassandra.
Okay.
And we have unstructured, we have Mongo. So we have multiple products.
Okay,
For your answer, right, the multi-tenancy.
Right.
Obviously, when it comes to multi-tenancy, there are a lot of choices. Whether you want to go to a shared database, whether you want a separate database, or you will go with a tenant-based column. So there are several factors. In Shiprocket, if you saw, there are many products. So like Shashi sir told, one of the product is warehousing. But there are many other products where where they are having shared architecture.
Okay.
So multiple tenants do share the data in some
So
place.
it's a use case basis.
Correct, use case,
Yeah.
one of these.
Thanks.
Okay. Thank you so much, Kavya.
Thank you.
Thank you so much,
everyone.
everyone.